So if you're given two functions and you're told to find f composite g of x, f composite g, and g composite f of x, that just means you're taking g and you're plugging it into the function f. Okay, so let's do that. So in red is the function g. I plug that in for x right here. Okay, and that's something we can simplify a little bit more. We can subtract the two 5s to make 8 over x over 2. And if you have trouble simplifying a fraction like that, because that's pretty crazy, here's something you can do. You can say that's equivalent to saying it's 8 division sign x over 2. Okay, because that is saying 8 divide x divide 2. So that's equivalent. And if you're dividing two fractions, you flip the second one and you multiply. So we get 16 over x. And so what we would say is that f of x and g of x, are not inverses of one another, because when we took f composite g, if they're inverses, you're supposed to get out just the function x. We got out 16 over x, so something different. So they are not inverses. And like it's supposed to go vice versa too. If you do g composite f, you're supposed to get out x if it's an inverse. And that's not what this x means. It just means it's a function of x. But if you do g composite f, you're supposed to get out x if they're inverses. And we'll see that we won't get that because we didn't get it when we did f composite g. This is g composite f because in red is the function g, x over 2 plus 5. So if I'm doing g composite f, that means I'm plugging in the function f in where x is supposed to go. So you can just take a look at those. That's where the x went, right here. And so we can simplify this.